Hey guys, the purpose of this video is to give you an example of how to construct a 95% confidence interval for two proportions for finding the difference. In particular, I've explored two celebrities, Blake Lively and Ryan Reynolds, and I want to see which one has a higher true proportion of solo pictures. Solo pictures meaning like they're in a video or they're in a picture by themselves, doesn't necessarily have to be a selfie, just something of them. Okay, so what I want to do is I've structured it so that you can kind of recreate that in a way that it's similar to what the graders for the AP exam would want to see. So it's following four different steps. We've got state, plan, do, and conclude. And if you follow each of these four steps, you're going to be a lot more successful on your AP exam. So for the first thing, for state, I want to look at what my variables are. So I state what my P of A, P of B represent. They represent the true proportion of solo pictures for Blake Lively and the true proportion of solo pictures for Ryan Reynolds. So in this case, I've decided that Blake Lively is going to be the person who takes more solo pictures. So you're going to kind of have to hypothesize which person you think is the greater of the two as well. Whoever you choose, whoever your two celebrities are. I also state what my P hat of A is and my P hat of B, which is my sample proportion. So for this exercise, I've chosen a sample of 30 Instagram pictures for both, and it's going to be represented by a random sample generated by a calculator. I also state what my N of A and my N of B represent, which is the sample size of how many pictures I chose for both celebrities. So the goal of this, again, is to conduct that 95% confidence interval. We're going to be calculating a critical value of 1.96, and you can find that critical value by finding the z-score for the middle 95% of your data on a normal curve. So what I've done is I have generated by my TI-84 calculator random integer, and notice that I've actually written down what I would plug into my calculator. And I've read that a lot of AP graders really like seeing exactly what you're plugging into your calculator so they know that you understand the problem. Okay, so there's 30 pictures here for Blake Lively, and there's 30 pictures here that were generated by random chance with Ryan Reynolds. And what I've done is the ones highlighted in red are the ones that represent solo pictures. So it was definitely fun going through 400 of Ryan Reynolds pictures. But every one of them, we found that 12 out of 30, so 40% of Blake Lively's pictures were selfies or solo pictures, and 26.7% of Ryan Reynolds' pictures were solo pictures. So this is me stating my variables, stating what those actual sample proportions are, and kind of outlining everything for the grader. And the next part is I'm going to plan. And the plan is to state the conditions. So each three conditions are normal, independence, and random. So you can see here that I've calculated that n times my p hat of A, that n times my 1 minus p hat of A, and the same for p hat of B. But notice in red I have this 8, which does not necessarily satisfy that normal condition. So you'd kind of want to make note for that for a free response problem, but for the purpose of this exercise, we're going to keep going. The next one is independence. Again, we found that 30 out of 44 of Blake Lively's pictures represents more than 10%, so that is an independent sample. However, for Ryan Reynolds' pictures, 483, 30 of them is only 6%. So this, again, does not necessarily tell us an independent sample, but we're going to just keep going. I did read, however, that in past AP exams, that testing for independence has not been a huge emphasis for AP graders, but they're definitely starting to look at all three conditions in equal amounts. So just make sure you're hitting on all three. The last one is random. So since we're doing the random integer on the calculator and getting a simple random sample of 30 numbers, this satisfies this condition. Okay, so for the next one, we want to do the actual confidence interval. So I outline what the formula I'm using, and then from there I'm plugging in my values and calculating that confidence interval from negative 0.103 to 3.369. Okay, and then my last step of my confidence interval is to conclude. So this top part right here represents where I've interpreted what my confidence interval actually means. So I'm 95% confident that the interval, that negative 0.103 to 0.369, contains the true difference in proportion of Blake Lively and Ryan Reynolds solo pictures. So since our interval does have that 0 in it, we have a negative to a positive value. That means that we do not have convincing evidence that the true proportion is entirely larger for Blake Lively. So we don't necessarily have evidence that Blake Lively is taking a higher proportion of selfies. And there's definitely a lot of red flags that come up because of our sample size. It's 30, so just think about what we could do if we had a higher sample size, and what would happen also if we increased our significance level or we decreased our confidence level. So I hope you guys, this kind of helped you get started on your two celebrities. One thing that I want to just kind of warn you is when you do start looking through those pictures, maybe don't pick someone who has like 3,000 pictures. But we are data collecting. This is statistics, so I hope you have fun with this.